Hello learners, welcome to this course on Arduino Mega Board programming and simulation. So in this tutorial, I will be discussing about on how to interface an ultrasonic sensor with Atmega 2560 microcontroller. So first, let us see the basics of ultrasonic sensor. So here we are going to use HC-SR04 ultrasonic sensor. So this ultrasonic sensor is mainly used for proximity sensing through non-contact measurement. So we can find the distance of an object from the sensor. So the basic construction of your ultrasonic sensor consists of a transmitter module, receiver module and a control circuit. So here the transmitter is going to generate the sound waves. This sound waves will be propagated towards your object. So depending upon the object distance, the return signal will get varied. The time to return signal will get varied depending upon the distance of the object. So once we compute the distance from the transmitter, the pulses reaches the object, gets reflected back and reaches the receiver. Once we find the time, we know the speed of the sound waves, which is 340 meters per second. So by multiplying the speed with the duration, we can compute the distance of the object from the sensor. So if the time is more, then the object is at a little bit longer distance. If the time is less, then the object is close to the sensor part. So the measurement range of the sensor is from 2 cm to 400 cm, and the ranging accuracy will be of about 3 mm. Measuring angle is about 15 degree, and the power supply requirement is 5 volt and 15 milliampere of current is required. If we look at the pin out of this ultrasonic sensor, we have 4 pins: VCC, trigger, echo and ground. So VCC and ground are power supply lines, whereas trigger and echo will be connected to the GPIO pins of your Arduino Mega Board. So for Arduino, we will have an output pin that will be connected to your trigger input pin of your ultrasonic sensor. And the same way, the echo signal from your ultrasonic module will be connected to the input pin of your Arduino Mega Board. So the basic logic behind this module working is, from Arduino we generate a trigger input pulse of 10 microsecond duration. Then using the echo output signal, we try to measure the pulse duration, which is proportional to the distance range. So we will see with the help of a graph. From Arduino, we generate this pulse, which is of 10 microsecond duration. As soon as this pulse is received by the module, sensor module, it will generate 8 pulses of 40 kilohertz frequency. This 8 pulses will get transmitted by the transmitter. And once it hits the object and gets reflected back, we try to capture those pulses. As soon as the pulse is transmitted by the transmitter module, the echo pin is set to high. And this echo pin will remain high until we receive at least 1 pulse of the 8 pulse which we transmitted from the transmitter. As soon as the pulse returns back, we try to set this echo pin to go to low. So then by measuring the time period of this echo pin, we can compute the distance of the object to the sensor module. So from Arduino, we generate this 10 microsecond trigger pulse. As soon as this trigger pulse comes to the sensor module, it will generate 8 40 kilohertz pulses and gets transmitted. So on reflection from the object, as soon as we receive that pulse, we set the echo pin to go from high to low pulse. Then we try to measure the time duration of this echo pulse. That gives the high level time, and this is multiplied by velocity of sound, which is 340 meters per second. Since this high level time is for the total round trip from transmitter to the object, from object to the receiver, since it is a round trip, we want only one way, from transmitter to object or from object to receiver. We divide this time period by 2 to get the distance of object from the sensor module. So now let us see how to interface this ultrasonic sensor with Arduino Mega Board. So we are going to write the embedded C program in an Arduino IDE environment, then convert this high level language program to a hexadecimal file. We are going to build our circuit using Proteus 8 Professional, and we are going to test the circuit also using this simulator. So by default, the Proteus will not come with this ultrasonic sensor module. So we have to download this library package and install in our Proteus environment so that we get this library package. So in order to do that, we have to go to this link and we have to download the ultrasonic sensor library package for Proteus, and they have given the steps for installing that library to our Proteus environment also. So I will show how to download this file and how to add this file to our Proteus 8 environment. Before that, let us discuss about the circuit part. So here we are going to interface this ultrasonic sensor to our Arduino Mega Board. So where I am going to connect the GPIO pin 14 to the trigger pin of your ultrasonic sensor, GPIO pin 15 of your Arduino Mega Board to echo pin of your ultrasonic sensor. Then we connect a LCD, 16x2 LCD, where I can display 16 characters in each row. We have 2 rows in the LCD. So we are going to configure the LCD in a 4-bit mode. So where I connect GPIO pins 5 to 2 to D4 to D7 pin of your LCD, and GPIO pins 12 and 11 to RS and enable pin of your LCD. So I strongly recommend to look at my earlier video on basics of LCD and on how to interface a LCD with Arduino Mega Board to have a better understanding on this connection diagram. So once this is done, we can import the hexadecimal file which we have created using Arduino IDE to this circuit, and then we can check the logic. So we try to measure the distance of the object to the ultrasonic sensor, and that value will be displayed on your LCD. So now let us go and see how to add the library into your Proteus environment. So in Google, you type ultrasonic sensor library for Proteus. So you will get this link, www.theengineeringprojects.com. So you can go into this. So here in this site, they have given a detailed explanation on how to use this library, how to install it, and they have also given some sample codes at the bottom. Step-by-step procedure is provided here. So how to interface it with Arduino, and they have given also some sample codes have been given. So you can go and download this library. You can go to ultrasonic sensor library for Proteus, click on it. Here you can find the document of ultrasonic sensor library for Proteus. When you press this, the RAR file will get downloaded. So you can extract this RAR file using a RAR software or zip software. Then once you do that, you will find 3 files in this library: ultrasonic tep.idx, ultrasonic tep.lib, and ultrasonic tep.x. So these three files you have to put it into the Proteus environment. In order to do that, you go to My Computer, C drive. So in C drive, by default, you will not visualize certain folders. So in order to visualize the hidden folders, you have to go to View, press this Hidden Items. So thereby you can see certain folders. So in that you will have program data. Go to this program data, Lab Center Electronics. You can find Proteus 8 Professional, and here you have a folder called as Library. So in this folder, you have to put those files, IDX file, library file, and hexadecimal file. You have to put it in this folder. Here you can see I have placed these three files: Ultrasonic TEP, Ultrasonic TEP, and Ultrasonic TEP.library. So these three files should be placed here. Then it gets added to your Proteus 8 environment. So once this is done, we can go back to Proteus to build our circuit. So let us create a new project. Select a folder where we are going to put our new project. So I will create a folder, Ultrasonic. Then give a name for the project. I'm going to use the same name, Ultrasonic. It should be with an extension of .pdsprj. Press next. Select a schematic. I'm going to select a default schematic. You can change the size of the schematic as per your wish. Press next. We are not going to create any PCB layout, so I'm going to leave it as it is. Press next. No firmware I'm going to use, so press next. So I have selected only the schematic part. So press finish. So our schematic window is open. So now in order to build the circuit, we need to select the components. For selecting the components, I go and pick the components. So first component which I am going to pick is Arduino Mega. Add it to your list. Then I require ultrasonic sensor. Select the ultrasonic sensor. Here you can find the module. Add it to your list. I also require a LCD. So we select a 16x2 LCD. LM016L, double click, add it to your list. And also I require a potentiometer. So select a potentiometer, HG type, add it to your list. So these are the components which I require for building my circuit. Once I have selected all the components, press OK to come out. Now I use this component to build the circuit. So first let me select Arduino Mega, place it onto my circuit. Then I am going to connect the LCD to my circuit. So let us see the connection diagram. You can see GPIO pins 5, 4, 3, 2. I need to connect it to D4, D5, D6, D7 of LCD. And pin number 12 and 11 of Arduino should be connected to RS and enable pin of LCD. So let us go and connect this. RS is connected to pin number 12. Enable is connected to pin number 11. D4 is connected to pin number 5. D5 is connected to pin number 4. D6 is connected to pin number 3. D7 is connected to pin number 2. So other pins are supply lines and data lines which we are not using. So we can connect it with supply and ground. So I am going to go to terminals mode, select power. I am going to place it onto the schematic, connect the supply to the VDD line. Then I select ground, place it onto my circuit, connect this ground to VEE, VSS, RW bar, D0, D1, D2, D3. So we have completed the interfacing of LCD with your Arduino Mega Board. Next, we have to select the ultrasonic sensor module. So again, go to components mode, ultrasonic sensor, place it onto your circuit. So for connecting this, let us again see the diagram. So here we need to connect the trigger pin to pin number 14 of your Arduino Mega Board and echo pin to pin number 15 of your Arduino Mega Board. So let us go and connect. So pin number 14 is connected to trigger pin of your ultrasonic sensor. Pin number 15 is connected to echo pin of your ultrasonic sensor. And remaining power supply and ground we can connect from terminals. So connect a power to 5 volt and ground to the ground. So here in this module you can also find another pin called as test pin. So this is available only in the simulation part. In the hardware you will find only these 4 pins: supply, ground, trigger and echo pins. The test pin is for the simulation, because here in the simulation we can't place the object at a certain distance, right? In order to mimic it, what we can do is we can connect a potentiometer to this test pin. So by varying the voltage to the test pin, we are assuming that the object is moving at a certain distance. So if I have a large voltage, meaning the object is at a long distance. If I have a small voltage, then the object is very close to the sensor. So by putting a potentiometer, we can mimic the object distance to the sensor. So to do that, again go to components mode, select the potentiometer, place it onto your circuit. Connect this potentiometer to the test pin. One end I am going to connect it with the supply. Another end I am going to connect the ground. So this completes our circuit. Few more steps we have to do before making a program to work properly. First thing is I have to import the corresponding hexadecimal file to the ultrasonic sensor module. So in order to do that, right click this ultrasonic sensor, edit properties, select the hexadecimal file. So that we have in our C drive, in program data, lab center electronics, Proteus 8 professional. In library we can find this ultrasonic TEP. So add this file, import this file to the ultrasonic sensor module. So now we have imported the X file related to ultrasonic sensor module in our circuit. Now we can go and build our embedded C program. Then convert that embedded C program into hexadecimal file. Then import that hexadecimal file onto the program memory of your Arduino Mega Board. So let us save this program and let us go to the Arduino IDE environment. So in Arduino IDE, we are going to build our program. So here the main objective is we need to measure the distance of the object, and this distance should be displayed on an LCD. So in order to use an LCD, we include this header file as include liquidcrystal.h, and we specify the connection diagram. So RS is connected to pin number 12, enable is connected to pin number 11, 5, 4, 3, 2 is connected to D4, D5, D6 and D7. And RW bar line is grounded. Then I define two variables. Trigger pin is set with a value of 14 and echo pin is set with a value of 15. Now in Arduino environment you will have two functions, setup function and a loop function. So setup function will run only for once, whereas loop function will run infinite number of times. So we make use of the setup function to do the configuration part. So in the configuration, first I am going to configure my LCD. So LCD.begin 16x2, which means I am going to interface a 16x2 LCD with our Arduino Mega Board. Then I define the two pins, trigger pin as well as echo pin. as an input pin as well as an output pin. Trigger pin is configured as an output pin, echo pin is configured as an input pin. So that configuration is done by this function called as pin mode. Then I set the cursor value for LCD at 0,0, which means first row, first position will be selected, and we try to print the message ultrasonic in the first row. And I change the position to second row. That is done by giving the cursor value to 0,1. And in the second row, I try to put the data, sensor data. So in order to retain this value for some time period, we use a delay function of 500 milliseconds. Then I try to clear the display. So once this is done, in a loop, we again define certain variables, duration, inches and centimeter, all of long time, which takes 4 bytes of your memory for storing these variables. So first thing what we need to do here is we need to generate the trigger pulse. Once this trigger pulse is generated, then the ultrasonic sensor module will start transmitting 8 pulses of 40 kHz frequency. So this trigger pulse should be of 10 microsecond duration. So to do that, first what we do, we set the trigger pin to low for some 2 microseconds, then set the trigger pin to high. And this high pulse will be retained for 10 microseconds. After 10 microseconds, it will come back to low. So ideally, we are doing a generation of 10 microsecond pulse on this trigger pin. So once this is done, the ultrasonic sensor module will generate the pulses and the pulses will get transmitted. Once it hits the object, it returns back and the receiver will receive the pulses. Once it receives the echo signal, initially after transmission of the pulses, it will be set to 1. On reception of the pulses, this value will go to 0. So we try to compute the duration of our echo pin value from the transmission of the pulse to the reception of the pulse. So that is done by this pulse in function. Pulse in function, echo pin, initially it is set to high after the transmission of pulses. So this pulse in function will keep on tracking the pulses return. Once the pulses return, the echo pin will go from high to low. So that duration will be taken here. Then this duration can be converted into different metrics, distance metrics, in terms of inches or centimeter or meters. So here I try to use 2 functions, one to convert your time to inch, another one is time to distance in centimeter. So we make use of these 2 functions from time to distance in inch and time to distance in centimeter. So here we use this divided by 2 because the time which we measure is for round trip time. We want only the one-way time from either the sensor to the object or from object to the sensor. So we divide the signal by 2. Once this is converted, inches and centimeter distance, we try to put the data in the LCD. So in the first row, I put in inches and I display the value in inches. And in the second row, we put in centimeter and we display the centimeter. So we measured the object distance and displayed it on the LCD. So once our programming is done, we can save this program. So I will create a folder on ultrasonic. Save this in the name ultrasonic.c. Then convert this program into the hexadecimal file. Once this is done, you can go and visualize the hexadecimal file. You can find the hexadecimal file here. I will open it with Notepad So this is the hexadecimal file which we are going to import onto our Arduino Mega Board. So let us go into Proteus environment, right click on this, edit properties, select the program file, ultrasonic, select the X file, okay. So we have imported the hexadecimal file onto our Proteus 8 environment. Now let us check whether it is working properly or not. So when I press play button, you can see ultrasonic sensor data and it prints in inches 219, in centimeter 560 centimeter. So now let us assume that my object distance is variable. So that is mimicked using by varying the potentiometer value. So I am going to increase this value. So as I start increasing, you can find the display also changes. As I start decreasing, you can find the value also gets decreased. So here the conversion factor which we have used is 1 inch equal to 2.54 centimeters. You can see as I start decreasing, meaning the object is coming little bit away from the sensor module. If I have the object very close by, then the time will be small. If the object is far away, then the time will be large. So that is mimicked by varying this potentiometer data. So in this tutorial, I have discussed on how to interface an ultrasonic sensor to your Arduino Mega Board, how to compute the distance and how to display it on the LCD. So thanks for watching. Please subscribe for more technical learning. Thank you.